balloon's being filled at a rate of 4 cubic feet per minute, and the rate in square feet per minute at which the surface area is increasing when the volume is 32 pi over 3 is, this is what we're looking for. So what we've been given here is the dV by dt, and that's equal to 4 cubic feet per minute. We're trying to find the change in surface area over the change in time. And we've been given here a volume is equal to 32 pi over 3. So what we could do is we need something to connect the volume to surface area, and we're going to connect the volume to surface area through the radius. Now we can try to connect the volume to surface area directly, but it's much easier to set it up this way, to have a volume equation in terms of radius and a surface area equation in terms of the radius. And what we're going to do is use the radius as an intermediary to be able to relate the two together. Now we could solve for r and substitute the surface area expression for r here, or vice versa, and then we can directly connect volume to surface area. But it's much easier to do this with the intermediary of the radius. So to do this then, I'm going to differentiate with respect to time. So I end up with 4 pi r squared times dr by dt. And so if I differentiate this expression, I get ds, the derivative of surface area over the change in time, is equal to 8 pi r. And then again, chain rule, dr by dt. And notice that we have a dr by dt that is common to both, and an r that's common to both. I can solve for the dr by dt by substituting in our parts. So 4 is equal to 4 pi r squared times dr by dt. And if I can figure out r squared, I can solve for dr by dt. Now I need another relationship. And that relationship is going to be my volume relationship, and that will connect my volume to the radius. And I can actually calculate the radius. So if my volume is 32 pi over 3, I know that's going to be 4 pi over 3 r cubed. I can solve for r cubed here. So in this case, 32 divided by 4 gives me 8 r cubed. R is equal to 2. So I can substitute my r equals 2 into that position there, and I can solve for dr by dt. Furthermore, when I need the r in the second equation, I can substitute the r there. So solving for dr by dt, I'm going to end up with the 4's cancel out, so I end up with 1 over 4 pi. That's my dr by dt. I now can then calculate my change in surface area and the change in time by substituting in all the parts that I know here. So r is equal to 2, dr by dt is equal to 1 over 4 pi. So the change in surface area over the change in time, when I simplify this all out, the pi's cancel. I get 16 over 4, or 4, and the units are going to be square feet per minute. So the rate at which the surface area is increasing the volume is 32 pi over 3 is going to be c, and that's 4 square feet per minute.